on storage classes in C. Myself, Ms. Priyanka Madanlal Channapattan, working as Assistant Professor in Computer Science and Engineering Department at Walchand Institute of Technology, Solapur. In the last video lecture, we have discussed first two type of storage classes, that is automatic and register storage classes. In this video lecture, we will see next two type of storage classes, that is static and external storage classes. Now let us see learning outcomes. At the end of this session, student will be able to identify the differences between static and external variable in terms of scope, lifetime and initialization. Apply static and external variables effectively in the programming to control data visibility and sharing. Next we will see storage classes. In the last video lecture, we have seen in detail storage classes in C. Now we just recap the definition of storage classes in C. Storage classes in C are used to determine the lifetime, visibility and memory location and initial value of a variable. Next, we will see types of storage classes in C. There are four types of storage classes in C language. First is automatic storage class, second is register storage class, third is static storage class and fourth is external storage class. In the last video lecture, we have discussed first two type storage classes, that is automatic and register storage classes. In this video lecture, we will see next two type of storage classes, that is static and external storage classes. Next we will see static storage classes in detail. The third type of storage class is static storage class. The static storage class in the C programming is a useful feature that allows variable to retain value between function calls. The static variable is stored in a memory. It is important to note that the actual storage for a static variable is allocated only once at the time of program execution. This means that the variable retains its value between function calls because it is stored in the global memory. If a static variable is declared with an initial value, then it is initialized to that value at the time of program execution. If it is not initialized, then it is initialized to 0 by default. The scope of static variable depends on where it is declared. If it is declared within a function or block, it is accessible only within that function or block. If it is declared outside any function, then it is accessible to all the function in the same file. If a static variable is declared within a block or function, its value is retained between function calls. This means that the variable retains its value even after the function or block has completed its execution. If a variable is declared outside of any function or block, its value is retained throughout the entire program execution. The static variable can be declared using the keyword static. For example, static int a. The static storage class can be explained with an example. In this example, the count function has a variable called count, initially set to 0. The static keyword is used to create a static variable, meaning that the variable value will be preserved between function calls. The count function increments the value of count by 1 and then return the new value. When a count function is called, it always returns the next value in the sequence, that is 1, 2, 3, etc. In the main function, count is called twice and the return value is printed using the printf function. When count function is called for the first time, the count function increments the value of count to 1 and printf print the value as 1. On the second call, the count increment to 2 and prints the value of count to 2 using printf function. So here the function count return the value of count by incrementing it every time and The main function is just calling the function and printing the returned value. The output of the program is count 1 and count 2. Next, we will see storage classes in detail. Next, we will see external storage classes in detail. The fourth type of storage class is external storage class. The external storage class in C programming enables a variable to be declared such that it can be shared and accessed between multiple source files. When we declared with the external storage class, variables are stored in a global memory and can be accessed by all the functions within the same program. The external variables are initialized to 0 by default. External variables have file scope, which means they can be accessed from anywhere within the file in which they are declared. External variables have global visibility, which means they can be accessed from any part of the program, including other files. The external variables have static lifetime, which means they are allocated memory once and remain in the memory throughout the program execution. External variable can be declared using the keyword extern. The extern keyword is used before a variable to inform the compiler that the variable is declared somewhere else. This can be explained with an example. In this example, global var is defined in a file 1 and it is declared with the extern storage class in file 2. The extern declaration in file 2 tells the compiler that global var is defined in another file, so it should not allocate storage. Instead, the compiler generates a symbol for global var so that it can be accessed in the file 2. The function display global is also defined in file 1 and declared with the external storage class in file 2. In the main function, a printf statement is executed, printing accessing external variable and displaying the value 10. Next, the display global function from file 2 is called, which in turn calls the display global function from file 1. The function prints the value of global variable, which is 10. The output of the program is accessing external variable 10 and global var 10. Next, think and write question. Question is, can a static variable be declared globally? Pause video and write your answer. The answer is yes, a static global variable is accessible only within the file where it is declared. This restricts access from other files, unlike external variable. Next, we will see advantages of storage classes in C. The first advantage is efficient memory management. The storage classes help in managing memory effectively by controlling the allocation and deallocation of memory for a variables and function. By using the appropriate storage classes, we can optimize memory usage and avoid memory leaks. Second advantage is code organization. Storage classes help in organizing code by controlling the scope and visibility of variable and functions. By using appropriate storage class, we can create modular code that is easier to understand and debug. The third advantage is faster execution. The storage classes like register can help in faster execution of code by storing frequently used variable in CPU register instead of RAM. This can lead to faster access and manipulation of data. The fourth advantage is flexibility. The storage classes provide flexibility in declaring variables and functions with different properties. We can choose the appropriate storage class based on the requirement of program, such as need for global and local visibility, static or automatic lifetime, etc. Next, we will see disadvantages of storage classes in C. The first disadvantage is complexity. Using storage classes can add complexity to the code, especially for the beginner who may not be familiar with the concept of scope, visibility, and lifetime. It may take some time and practice to understand and use storage classes effectively. The second disadvantage is overuse. Overusing storage classes can lead to confusion and make the code harder to understand and maintain. It is important to use storage classes only when necessary. The third disadvantage is portability. Some storage classes like register are hardware dependent and may not be supported by all compilers or platforms. This can affect the portability of the code. The fourth disadvantage is limited control. The storage classes provide limited control over memory allocation and deallocation compared to dynamic memory allocations using functions like malloc and calloc and free. These are the disadvantages of storage classes in C. Next, these are the references. Thank you.